In our first example, for solving by isolating trig expression, we're going to try and get sine x to be by itself. Now keep in mind, even though we're working most of the time with x, it would be the same thing if it was sine theta. So let me specify 3 sine theta and 4 sine theta. The theta and the x are unknown variables, so they're the same function, just different form. So most of the time we're going to be working with x, but if you see a problem with theta, it's just the same thing. Now, in our first example, it's 7/2 plus 3 sine of x equal 3 plus 4 sine of x. So typically what I am used to do is have the variable on the left side. Now you can still work it out and have the variable on the right side. As long as you do it correctly, your answer should match with my answer. So typically, I have my variable on the left side, but it's okay if you choose to have the variable on the right side. Again, as I stated before, there's multiple ways of solving a problem and get the same answer as long as it's done correctly. So I want to get rid of 4 sine x from the right side, so I'm going to subtract 4 sine x. So typically how we would solve a normal equation, so on the left side I'm still going to have 7/2. 3 sine x minus 4 sine x, that will be negative sine x, equal to 3. Alright, now I want to get negative sine x to be by itself, so what I typically do next is get rid of the number, so the 7/2. So what I'm going to do with the 7/2 is, in order to get rid of it, I'll do the opposite, so going to be minus 7/2 on the left, and then minus 7/2 on the right. So on the left, it will be negative sine x equal, since it's a whole number subtracted by a fraction, I'm going to write it side by side. So 3 minus 7/2. Alright, and just like how we did on all the tests, working with fraction, I'm going to convert this into a fraction with a common denominator. Now, again, this should be a easy method to do. So, I'm not going to write out all the steps. We have done it numerous times on a test, so this should be natural to you. So, negative sine x equal 6/2 minus 7/2. Now, if you have any question on how I got that, I would recommend to refer back to your notes, your previous notes of previous sections, go back to your test, see how you worked with, again, fraction of common denominator. So I'm going to write this part over here for more space. Now, since we have negative sine x equal 6/2 minus 7/2, it will become negative sine x equal to negative 1/2. Alright, we're almost done. So what we need to do is try to get sine x without the negative. So in order to get rid of the negative, I'm going to do the opposite, which is divide by negative 1 on both sides. So we're going to have sine x equal to positive 1/2. Alright, but we're just not done. We're just basically 3/4 the way. Now we have to determine the value of x, meaning the angle measure. So if we go back to our unit circle, which I provided on its learning, the field information, which looks similar to like this. So basically, we look for what angle measure, and I'm going to give you in degrees and radians, where sine x equals 1/2. So if we zoom in closer, Sine x are typically the y values. So these, the one on the right, are the y values. Those are the values for sine x. The one on the left, 1/2, square root of 2 over 2, square root of 3 over 2. Those are the x values, or values for cosine of x. So typically, we're going to look for the values that are on the left. So here, coincidentally, there's 1/2. That's the one we need to look. So that's 30 degrees, or pi over 6. Now, typically, we just look at the whole unit circle, but because we're always going to be assumed that it's from 0, 1 full circle to 2 pi, or 0, 1 full circle to 360 degrees. So we found our first answer, which is pi over 6 or 30 degrees. Now we look at where it's also on the board, it says positive 1/2, so that means quadrant 2, because the y values that are positive is in quadrant 1 and quadrant 2. So for quadrant 2, I look where it says cosine of 1/2. So here, square root of 1 is 1, so that basically means 1/2. So this one right here. So where sine is positive 1/2, it's 150 degrees, or 5 pi over 6. So the answer for sine x equals 1/2, if I were to ask you in degrees, it would be 30 degrees and 150 degrees, as shown that it appeared twice in quadrant 1 and quadrant 2. Now if I ask you in radians, for 30 degrees, that is pi over 6. And for 150 degrees, that will be 5 pi over 6. So depending on the question, and most of the time it will be in radians, but sometimes I might ask in degrees. The value of x, where sine of x equals 1/2, is 30 degrees and 150 degrees, or 5 pi over 6 and 5 pi over 6. So those will be our answer if I ask you in degrees, or if I ask you in radians. So for the value of x, where it equals to 1/2, if I ask you in degrees, 30 degrees and 150 degrees. If I ask you in radians, pi over 6 and 5 pi over 6. In our second example, we have negative 6 cosine of x equal 4 plus 2 cosine of x. So if we were to take a look, variables on both sides and a single number, I see that the single number is on the right side of the equal sign. So that means I'm going to get all the variables to the left. So I'm going to get all cosine of x to the left side. So in order to cancel out plus 2 cosine of x, I'm going to do the opposite, which is negative 2 cosine of x on the right side, negative 2 cosine of x on the left side. Alright, so the 2 cosine of x will cancel out on the right. So on the left side, it will be negative 8 cosine of x equal to 4. And then after that, if I want to get cosine of x to be by itself, I'm going to get rid of the negative 8, which I'm going to do by dividing by negative 8 on both sides. So I'm going to have cosine of x equal to negative 4 over 8, which can be simplified to cosine of x equal to negative 1/2. Alright, so it's going to ask you what value of x, meaning what angle measure for cosine, that will equal to negative 1/2. So without looking at the unit circle, if I'm trying to find where cosine of x equals negative 1/2, meaning that my x value is negative. So if I were to look on the unit circle, The only quadrant where the x value is negative is in quadrant 2 and quadrant 3. That's without looking at a unit circle, basically remembering from the xy intercept. I mean the xy axis. So where the x values are negative, that is between quadrant 2 and quadrant 3. So right here, these two. I'm basically looking at what angle measure when it's negative 1/2. So by looking at these, I see that we have a negative 1/2 right here. So basically at 120 degrees, or 2 pi over 3. Then also down here where cosine, again as I stated before, the values that are on the left, that's for cosine. Here is negative 1/2, so that means at 240 degrees, or 4 pi over 3. So we have two answers for degrees, two answers for radians. So for cosine of x equals negative 1/2, for the angle measure for x, if I were to ask you in degrees, I would say 120 degrees and 240 degrees. If I were to ask you in radians, for 120, it would be 2 pi over 3. For 240 degrees, it would be 4 pi over 3. So those will be the final answer for x to find cosine equal to negative 1/2. Now, like I stated before, in chapter 4, in order to understand the unit circle, you need to understand quadrant 1, see how it's related to quadrant 2, and see how quadrant 1 is related to quadrant 4, then see how quadrant 2 and 4 is related to 3. So, to review with this example, the value of x for cosine equals negative 1/2. For degrees, it's 120 degrees and 240 degrees. For radians, 2 pi over 3 and 4 pi over 3. In our third example, we have negative 1 plus 2 sine of x equal 1 plus sine of x. So, I'm going to try to get all the sine of x on the left side. So I'm going to cancel out with plus sine of x with negative sine of x. Did it on the right side, you're going to do it on the left side. So I'm going to have negative 1 plus sine of x, because 2 sine of x minus sine of x, or minus 1 sine of x, will be plus sine of x equal to 1. And then I get all the numbers to the right side. So here I'm going to cancel out with the negative 1 by writing plus 1 on the left and then plus 1 on the right side. So sine of x equal to 2. Alright, so basically we're trying to find the value of x, the angle measure, where sine of x equals to 2. So if we were to do one full circle of the unit circle, if we were to look, I'm looking for my value of 2, which is the right values of each for sine of x. Now I'm looking, I don't see anything where it's just simply a whole number of 2. Everything else, if I'm looking at the whole numbers, which is at 0 degrees, 90 degrees, 180, 270, or 0 or 2 pi in radians, pi over 2, pi, 3 pi over 2, the only whole numbers I'm looking at is 0, negative 1, and 1, which are not the same as 2. So, and if we're looking at all the other exact values, they're all in fractions, none of them matches with a whole number of 2. So as I'm taking one final look at the exact values for sine of x, where none of them has 2, so what it means that if it's not on the unit circle, that means that there is no solution for x. That means you won't find a value for x where sine of x equals to 2 on the unit circle. So the only thing you can do is just say no solution. Because as shown, and as you take a look at the unit circle from your notes, you cannot find an angle measure where sine of x equals to 2. So that's why we're going to have no solution. And that's all you would have to write as your final answer, no solution. So again, to review, the reason we had no solution was we were unable to find an angle measure on the unit circle where sine of x equals to 2. If you can't find one, then you're at no solution. Now the only whole numbers that we deal with is 0, -1, and 1. And for our exact value is typically a fraction. Now, that's for sine and cosine. Tangent, you have to remember how to get the values using the quotient identity, sine of x over cosine of x. There's some with fractions. There's one with a whole number, square root of 3, where it's not a fraction. And then there's one where it's undefined. So make sure to remember that for the values of tangent for those special angles. But in this example, it's no solution.